Let's now take a look at question number 45. This is one of our radical equations. In order to solve these, what you want to do is get a square root by itself on one side of the equation, and then you can go ahead and square both sides. The square root and the square cancel, so it would give us 7x minus 6 equal to 6 squared is 36. From here we would need to add 6 to both sides. We get 7x equals 42. Divide by 7, divide by 7. We get x equals 2 to 6. One of the things you have to be very careful with whenever you solve a square root equation is you should always check these answers. As a result of squaring both sides, it's possible to create an extraneous solution. If you plug 6 back into the original, 7 times 6 minus 6, is this truly going to be equal to 6? Well, 7 times 6 is 42. 42 minus 6 is 36. And it is true that the square root of 36 does give us 6. So plugging it back in, it does check out. So the solution is x equals 2 to 6. If we take a look at question number 46, again, we want to get a square root on one side by itself. We already have that. So we can now proceed to squaring both sides. The left-hand squared gives us x squared equals, on the right-hand side, the square root and the square cancel. So we get 6x plus 7. This ends up being a quadratic equation. We need to get one side to 0. So I'm going to subtract 6x and subtract 7 from both sides. X squared minus 6x minus 7 equals 0. It's a quadratic. This one will factor nicely. It factors as x minus 7 times x plus 1 equals 0. We set each factor equal to 0. And we get two proposed solutions. The first one's going to be x equals to 7. The second one's going to be x equals to negative 1. As I mentioned a moment ago, whenever you square both sides of an equation, you have to go back through and check those answers. I'm not going to show the work this time, but if you plug 7 back in, I guarantee you that one will work. So one solution will be x equals to 7. However, if you try to check the solution x equals to negative 1, that one will not work. That one ends up being an extraneous solution. So we just get one solution to this problem, and that's x equals 7. Let's take a look at number 47. This is multiplication of two complex numbers. To do this, we're going to FOIL. 6 times 3 is 18. 6 times 3i is 18i. Negative 2i times 3 is negative 6i. And then negative 2i times 3i would give us a negative 6 with an I squared. Okay. We can combine our middle terms. 18i and negative 6i would give us a positive 12i. And then wherever you see an I squared, remember I squared is equal to negative 1. So I'm replacing I squared with negative 1. It becomes 18 plus 12i. Negative 6 times negative 1 is a positive 6. And then I can combine my like terms. 18 and 6 is 24. So our final answer is the complex number 24 plus 12i. In question 48, they want us to solve this quadratic equation, and this one can be solved using the square root property. We have a perfect square quantity, which is right here. We can isolate that by, first of all, adding 10 to both sides. And actually, this is a typo. This should be equal to 0, as it was written on the review sheet. So it's going to be plus 10, plus 10. That gives us x plus 3 squared equals to 10. Now that we have the square by itself, we're going to solve by taking the square root. Whenever you take the square to the right-hand side, that's a number. Don't forget you need your plus minus. This gives us x plus 3 equals plus or minus the square root of 10. And then we have one more step to get the x by itself. I would need to subtract 3 from both sides. So we're going to get x equals negative 3 plus or minus the square root of 10. Okay. So those are the two solutions. One is negative 3 minus the square root of 10. The other solution would be negative 3 plus the square root of 10 if you wanted to split it apart and didn't want to use the plus minus notation. in question 49, they ask us to solve this by using the quadratic formula. First of all, you have to have one side set equal to 0, which we do. Then we want to identify the coefficients. The A is going to be 1, the B is positive 12, and the C is 22. You have to know the quadratic formula for the final. The formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Let's go ahead and take our time and plug everything in nicely. It's going to be negative 12 plus or minus the square root of 12 squared minus 4 times a times c, all divided by 2 times a. Once we have everything plugged in, it's just a matter of using order of operations to work this out. Underneath the radical, 12 squared is 144. We have negative 4 times 1 times 22. That should give us a negative 88. We get x equals negative 12 plus or minus 144 minus 88 is going to be 56. All divided by 2. This will reduce some. The perfect square 4 goes into this 56. So we can write this as the square root of 4. 4 goes into 56 14 times over 2. This is negative 12 plus or minus 2 radical 14 over 2. And as it turns out, both terms in the numerator have a factor of 2, and there's also a common factor of 2 in the denominator. So we can divide that out. 2 goes into negative 12, negative 6 times, and 2 would go into itself 1 time. So our final answer is x equals negative 6 plus or minus the square root of 14. So our two solutions are negative 6 minus the square root of 14 and negative 6 plus the square root of 14.